Hello everyone, this is Jason. Today Tesla officially put Terafab into its public job listings. This is no longer just a concept. It is the moment Elon Musk personally pushes Tesla's chip strategy from design all the way into in-house manufacturing. Tesla appears ready to build its own advanced AI wafer fab and take control of yield cost and speed. That could remove a major compute bottleneck for full self-driving Optimus and Robotaxi. Do not miss today's episode. Get into it. First, Terafab is officially underway. For a long time, critics said Tesla still had to rely on TSMC and Samsung no matter how strong it looked. But today, Terafab moved into the open. This is a crucial step in taking Tesla from chip design to wafer production and pushing vertical integration to the extreme. Tesla posted 7 dedicated Terafab roles on its official website, and every one of them is related to silicon manufacturing. This is the first time Tesla has acknowledged the Terafab name in formal hiring, and that matters because it shows the project has moved from idea to execution. From those job listings, this is clearly not ordinary hiring. Tesla is staffing for a brand new AI chip factory and wants to control everything from capital spending and infrastructure to supply chain and process integration. One opening for a silicon module process engineer is especially revealing. Tesla says it wants a highly motivated engineer covering lithography, etch deposition, epitaxy metal implant polishing, and related fields to accelerate advanced system-on-chip development. The role also calls for working across global teams to achieve leading process performance, yield, and reliability. The responsibilities read like a wafer fab battle plan. Tesla wants end-to-end ownership from installing new tools to ramping mass production. The engineer would lead tool installation and qualification support to transition into high-volume manufacturing, keep global factories aligned, work with equipment suppliers on next-generation module technology, reduce cost, and push yield improvement while helping solve urgent production issues around the clock. In simple terms, Tesla is not just designing chips anymore. It wants to build the entire fab from scratch and control speed, cost, and yield itself. Many people still worry Tesla depends too heavily on outside suppliers, but Musk has shown concern about this for a long time. He has said that even if you combine the best output from all major suppliers, it still would not be enough over the next 3 to 4 years. That is why he believes Tesla must build this fab in the United States. Yes, this is a brutally difficult path. A wafer fab can require tens of billions of dollars, ultra-clean facilities, and vibration control stricter than what many people imagine. But Tesla has already shown with batteries and cars that it can turn the impossible into scalable production. By pulling chips into its own stack, Tesla would cut supply chain risk, accelerate iteration, and drive costs down. Once Terafab begins ramping, Tesla's AI compute may stop being a bottleneck. Cybercab, large-scale Optimus deployment, and future Dojo upgrades could all move much faster. That is why this matters so much. Musk is not only trying to sell cars and robots, he wants Tesla to sell AI brains to the world. This could be the real starting point for Tesla's AI empire. If you enjoyed this breakdown, please like and subscribe. Your support means a lot. Now to part 2. Musk may be putting about $2.9 billion into Chinese solar equipment. Power demand in the United States is surging as AI data centers expand, and the grid is aging fast. Reuters reported that Tesla is discussing a deal with several Chinese suppliers, including Suzhou Maxwell Shenzhen, SC New Energy, and Laplace Renewable Energy. The total value could reach about 20 billion yuan. The equipment would be used to make solar cells and panels with a target of building 100 gigawatts of annual capacity in the United States by the end of 2028. This is a huge number. In 2024, total U.S. generating capacity was about 1,300 gigawatts, and solar accounted for only a little over 10%. At the same time, AI and manufacturing are driving electricity demand sharply higher. Musk said earlier this year that solar could meet the country's entire electricity demand, including explosive data center growth. In an earlier video, I mentioned that a Tesla team had recently visited China to inspect solar manufacturing equipment and supply chains. That trip now looks like an early step toward this larger deal. Chinese media reported in early February that delegates from Tesla and SpaceX quietly visited companies such as GCL and Jinko to examine wafer equipment, perovskite technology, and possible U.S. factory plans. At the time, Chinese solar stocks jumped on the news. Now it seems that visit may have been a scouting mission for this order. Some equipment could begin shipping this autumn, and at least part of it may go directly to Texas. Tesla would use much of the capacity itself, and the rest could also support SpaceX. This is a true full-stack energy strategy. The interesting part is policy. The United States has imposed heavy tariffs on Chinese solar panels and batteries, but has exempted manufacturing equipment. That policy began under Biden and continues under Trump for a simple reason. America still cannot build production lines that are this efficient at this cost. Musk's move is pragmatic. Use the best Chinese equipment, build factories on American soil, hire American workers, and make the finished product in the United States. Chinese firms have excess capacity at home, so selling advanced equipment abroad fits their needs as well. This is less about dependence and more about strategic leverage. Still, some of the equipment must pass Chinese export review, so timing remains uncertain, and geopolitics is always a risk. Even so, this order suggests Tesla Energy could be entering a major expansion phase. Musk may be using the fastest and lowest cost path to lift U.S. solar manufacturing capability toward world-class scale. That would mean Tesla is not just selling cars, batteries, and megapacks. It could also become a serious seller of American-made solar products. No slogans, just a direct all-in move on the most efficient path. For part 3, let us look at other automakers. Xiaomi has launched a new SU7 with a starting price of 19,900 yuan, or roughly $31,900 US. That is below the earlier pre-sale price and makes its market position even more aggressive against rivals such as the Tesla Model 3, which starts at 235,500 yuan in China. Although the new SU7 is slightly more expensive than the first version launched 2 years ago, the new pricing shows Xiaomi is trying to keep strong value while adding more features. The lineup now includes Standard Pro and Max. The entry model uses a 73 kilowatt-hour battery and offers a CLTC range of 720 kilometers. The Pro jumps to a 96.3 kilowatt-hour pack and claims 902 kilometers. The Max uses a 101.7 kilowatt-hour battery and range is lower at 835 kilometers. It adds dual motor all-wheel drive and can go from 0 to 100 kilometers per hour in just over 3 seconds. Xiaomi is clearly trying to hit performance and value at the same time. What is even more striking is the hardware. Every version comes standard with LiDAR, a 4-dimensional millimeter wave radar, an NVIDIA Store computing platform with 700 TOPS of compute running Xiaomi's own cognition model. Safety is also a major selling point. The body uses ultra-high-strength steel up to 2200 megapascals. There are 9 airbags and stronger battery protection for extreme conditions. Charging is another highlight. Under the high-voltage architecture, the Max can recover about 600 TOP72, a premium tech look with large screens, a rotating display, voice control, and more luxurious materials. With this pricing, Xiaomi is putting direct pressure on the Model 3 by offering more technology at a lower price. The first-generation SU7 has already delivered more than 381,000 units, and Xiaomi wants total brand sales to reach 550,000 units in 2026, with the SU7 as a core contributor. Even more interesting, the company is also eyeing Canada, where tariffs on Chinese-made EVs are now only 6.1%. That could give the SU7 a real chance to enter the market and create fresh competition for the Model 3 and Model Y. I will keep watching its sales closely. On the other side, Rolls-Royce is turning more cautious. This ultra-luxury BMW-owned brand launched its first EV, the Spectre, in 2022 and had once declared it would fully abandon the V12 and become an all-electric brand by 2030. But now Chief Executive Chris Brownridge says some customers still want the V12 because it is part of the brand's history, and both the regulatory environment and market expectations have changed. So Rolls-Royce is no longer treating 2030 as a hard deadline. Spectre will continue, but the company wants flexibility rather than an absolute switch. That is not an isolated case. Ford, Volvo, and Honda have also slowed or adjusted parts of their EV plans. The lesson is clear. The transition to electric vehicles is proving harder and less linear than many expected. These two stories show the market splitting in different directions. Chinese newcomers are charging ahead with technology and aggressive pricing, while traditional luxury brands are becoming more pragmatic and adapting to customer demand. Which side are you more optimistic about right now? Finally, let us talk about one more Musk prediction. He said that in just 3 years, Tesla's Optimus humanoid robot could surpass the very best human surgeons and become a better surgical expert. His argument is that the world faces severe shortages of doctors and especially elite surgeons, while human beings are limited by time fatigue and biology. In that view, Optimus could become a scalable surgical solution that can be deployed rapidly around the world. It is an extremely bold and controversial claim. Many medical experts and people in surgical robotics say reaching that level within 3 years is not realistic. But Musk has always used aggressive timelines to push technology forward. Would you trust a robot to perform surgery on you? Thanks for spending your valuable time with me today. Leave your thoughts in the comments, and if you want more coverage in these areas, Please like and subscribe. This is Jason. See you next time.